I'm going to be demonstrating trying to use computational techniques to build molecular designs that can be used for single molecule magnets. So basically what I do is first, I try to select organic molecules that I can use to form a compound with a metal. So what I do first is to move into a sign finder in the internet and then just sketch whatever molecule I want to do so that I can see other variations of it that are either have been published or are just there but have not been published. So with that, I can then look at what property these ligands might possess by running a series of calculations on them to look at their electronic structures. And if these electronic structures are of interest, then I can move to the lab, give it to a synthetic chemist to synthesize this molecule, and then use real-world machines to test those properties and see if what I bring out from my computation is actually the same thing with what I have fabricated. So right now I'm going to kind of move to the lab to demonstrate how one or two skills that I might need. So this is a typical organic ligand that we are going to be using today to form a complex that we can now test its property, be it magnetic property or whatever it is. So I've drawn this on ChemDraw, and all I have to do is to see if there have been a report about this. And I just go to search and try to search this on Sign Finder, and then gives me different modification of that particular ligand. So today, looking at this, I can see the existence of some sort of a minus sign in there. So that means that I could use this to react with a metal and they can exchange that sign. So that's the reason I'll be using this particular one, which is a saccharin, to complex with copper to get a metal complex. Because of the copper in there, I'm sure that we can look at the magnetic property. As a scientist, you look at properties, you try to judge from the properties, is there any other way I can apply this compound that I have made to solve whatever human problem. So this saccharin is usually used as a sweetener. It can be used on your toothpaste. It can be used on so many other things that you want the taste of what you are trying to give out to your consumer to be very sweet and all that. But because of the concern that it might have some carcinogenic effects, people are beginning to drive away, move away from this. But that doesn't mean that the molecule is completely useless. So we can transform this molecule by forming a complex with other metal and then trying other properties of the molecule, like magnetic property, which is what I'm going to be doing today. So I'm going to be reacting this compound with copper, a copper sulfate, so I can form a complex that I can now move ahead, characterize, and then look at what property it will have, basically electronic and magnetic property.